this type. We're going to see this when we deal with our acids quite a bit. All right, so this is hydrocyanic acid. Not that that matters, but we have aqueous, and I'm going to go ahead and take advantage of that being right there. Nice and straight line there. It says a 0.2 molar solution of this acid. So anytime it tells us that, we're going to start that out right there. All our acids will look like that. And it doesn't mention in the beginning any of these hydrogen ions or the cyanide ion. So we're going to let those be 0. All right. It does give us a K value, which is going to tell us that we're going to have X's in our equilibrium expression. And I'd like you to look at the value here. It is 6.2 times 10 to the negative 10th. That's a really, really small number. Okay, and so that's going to mean something to us as we get ready to write this problem. So because I know this, I know that I can use X's in my equilibrium expression. So I'm going to be using X's in my table. All right, so I know because these are 0, I have to add on this side and I have to subtract on this side. And I don't know how much, so I'm going to subtract X amount. For every one of them, I get one of them. Remember, if there had been a 2, we'd put 2, so that is important. And for every one, there's 1. So these are all 1 for the change. So then we're going to get 0.2 minus X. 0 plus X is going to equal X. 0 plus X is going to equal X. Then it's going to be the products. So you're going to end up with X times X, or can I just say X squared on top, and it's going to be over 0.20 minus X, and that is set equal to the K. So it's 6.2 times 10 to the negative 10th. Now, like before, I can't take the square root of both sides because the bottom is not a perfect square. But this is neat because this is something called the 5% rule, and we'll learn it more. But as long as this number here, the K value, is really small, and when I say small, 1 times 10 to the negative 5th or smaller. Negative 4th sometimes will work, and I'm going to teach you when we do acids how to tell whether or not this will work or not. But negative 5th or smaller. So negative 10th is definitely smaller than negative 5th. So this is work. So this is called the 5% rule. And what it lets you do, it lets you take this minus X because it's going to be such a small value and it's going to be almost insignificant when we round back up. And it's going to allow us to mark through that. Why is that important? Well, now we don't have to deal with a quadratic formula. And so I could now multiply both sides by 0.2. Right? And then I could take the square root of it to get my X, and I could find my X to be 1.1 times 10 to the negative 5th. And it asks for the H plus concentration, which is just X, so that is my answer there. Okay, so that as long as it's times 10 to the negative 5th or smaller, you can mark through the minus X on the bottom. And we will use that a lot when we deal with the weak acids. It's a little rule that you're going to enjoy, I think.